Hello, welcome to this course on Computational Commutative Algebra. I am Manoj Kumini and I teach at Chennai Mathematical Institute. So in this short video, I will try to give an introduction to this course and what we will learn, etc. Okay, so first we'll discuss a little bit about the course, then we'll talk a little bit about Macaulay 2, which is the program that we will use to learn to compute things about rings, modules, etc. And then I will describe the contents of this course, the vague contents of this course. So this is a course on computational commutative algebra. So it is meant as an introductory course in commutative algebra, which means that we don't assume a lot of prerequisites. Basic knowledge about rings and modules would be more than enough. And everything else about commutative algebra we will develop in the course. At the same time, we will also put a lot of emphasis on computations. In other words, what are things that can be computed about rings or ideals algorithmically. So we will use, there are programs available for these things, and we will learn to use a program in that thing. At the same time, we will also try to learn what is going on in these computations. Not every computation can be explained in this first course, but at least the basics, the introductory part, we will learn by the end of this course. So that is the extremely sketchy outline of this course. I just said there are many programs that do these sort of computations. We will use a program called Macaulay 2. There is similarly a program called Singular. There is a program called Cocoa, all of which more or less will be able to do the basic computations that we will learn in this class. They have different syntax, different strengths, different weaknesses. So we will concentrate on one, and hopefully by being able to use one properly, at the end of this course you will be able to do it in a different computer algebra system also. So this Macaulay 2 is freely downloadable from its website. And if you only need some small computations, there is no need to download it and install it on your personal machine. You can just do it on the web itself. There are web forms where you can input small amounts of code and it will compute on some public server. And there's extensive help for Macaulay 2, both on its website, and there are discussion groups discussing how to achieve various things in Macaulay. And with the installation, that if you install it locally, then along with the installation, you would get a help. So there is extensive documentation. So here I'll go over the content of this course. So we will begin by studying rings, ideals, and modules. And we will prove typical results that are proved in a first course in commutative algebra. So essentially, we will learn everything from scratch. However, the pace might be slightly different because we also have to incorporate computational aspects, and we may not prove all the results in the typical generality that is proved in a course in commutative algebra, because we would like to emphasize things that can be proved about things that in which computational techniques are effective. And we will use Macaulay to study examples, to illustrate some steps in the proof, or even try to solve problems using this. That's one of the goals of this course, that at the end of it, you will be able to use it to solve your own problems or set them up and get some hints from Macaulay as to what could be true and what could not be. So in the first 2 to 3 weeks, we will learn the basics of how some computations are done. Next week or so, maybe 2 weeks, of associated primes and primary decomposition. Another 2 weeks, integral extensions, Naize normalization lemma. Another 2 weeks about Hilbert functions and dimension theory. And then along, we will apply these things in geometric contexts. So we will try to spread this 1 week of work throughout the semester as much as possible. But if there is some application that's left over, we will try to do it at that point. Then for about 2 weeks, we will do homological algebra, learn a little bit about Koszul complexes, Ext and Tor, and the Auslander-Buchsbaum formula. Okay. And please bear in mind that these are approximate time periods. Some topics may not take as much as what is mentioned here. Some may take longer, and will adjust accordingly. Okay? So I hope that you enjoy the course, and if you need further information, please feel free to email me, and that is my email address.